Hello everyone, today we are presenting our project titled COVID-19 Country Insights, an aggregated data management system developed for the module Service-Oriented Computing at Horizon Campus. This project demonstrates how multiple public APIs can be integrated into a single service-oriented system to collect, combine, and store real-time country and COVID-19 information. So the background of the project: in today's digital environment, many applications rely on external APIs to deliver real-time information. Our project follows these principles. We use two different public APIs, extract useful data from both, and combine the result into one meaningful output. This shows how distributed services communicate to support decision making, especially in areas like public health and travel. When it comes to the purpose of the system, the main purpose of the system is to collect country metadata and COVID-19 statistics, aggregate them on the client side, and securely submit that data to backend web service. The backend validates the data using OAuth 2.0 and API key before storing it in MongoDB. When it comes to the client-server architecture overview, our system follows a client-server model. The client fetches data from two APIs, merge the results, and send them as a JSON object. The server verifies the request, stores the data, and allows retrieval through REST endpoints. When it comes to objectives, the general objective is to design a secure service-oriented system that integrates external APIs and store validated records. The specific objectives include consuming at least two public APIs, aggregating their data, enforcing OAuth 2.0 and API key security, storing data in MongoDB, providing retrieval endpoints, and presenting results through a user-friendly interface. When it comes to system architecture and data flow, here is the high-level architecture. First, the user selects a country. Next, the client fetches data from both APIs. Then, the information is merged into one JSON object. That object is sent to the backend with OAuth and API key headers. Then, the backend validates and stores it. Finally, the records can be retrieved via record endpoints. So, thank you. Now, I will hand over to Dilmi.
Now we are looking at public APIs used. Our system uses two external APIs. The first one is the RestCountries API, which provides details such as population, capital city, currency, flag URL, and regional information. These fields help us build a detailed profile of each country. As you can see, this is a sample API response. So moving on to the second API, that is COVID-19 disease API. This API provides real-time pandemic statistics including total cases, daily updates, deaths, recoveries, and active cases. So this is a API response of that. So when it's come to client-side implementation, our client is built with HTML, CSS, and JavaScript. We use the Fetch API to contact both public APIs and our backend services. Google OAuth 2.0 is implemented for secure login, ensuring that only authenticated users can send data to the server. The user interface is designed to be simple, responsive, and user-friendly, allowing users to fetch real-time data, view aggregated results, and submit them. This is a user interface overview, as you can see. Let's move on to key client functions. So there are Google Auth login button. So this is the code of that. And the second one is fetch API calls to public APIs, and also aggregation logic. Next one, post request sending to the final JSON to the backend, and display components. This one. So this is a screenshot of client UI. Let's move on to backend implementation. The backend is built using Node.js and Express.js. It exposes two main endpoints, post submit, that used to store aggregated records, and get records used to retrieve store data. Before processing a request, the backend checks the auth token and validates a custom API key to ensure the request is secure. So when it's come to MongoDB database structure, our MongoDB database stores aggregated data in structured document format. Each document contains country name, country metadata, COVID stats, timestamp, submitted by who. This format keeps our data organized, flexible, and easy to query. Nirmani.
Thank you, Dilmi. Now I will explain the security features implemented in our system. We have added several important security measures to ensure safe and reliable access. First, OAuth 2.0 authentication is used to make sure that only logged in users can access the system. Next, we used API key validation, which helps verify that all requests are coming from trusted clients. We also apply input sanitations to protect the server from harmful or unexpected data. All communication happens over HTTPS, ensuring the data is encrypted during transmission. Finally, we have rate limiting, which help prevent abuse, protect the server from overload, and improves overall stability. You can see the code snippet shown below. Second one is testing and evaluation. To test our backend, we used Postman to validate each point during the test for the getRecord endpoint. We included both the authentication header and our API key. The server responded with 200 OK status and returned all stored documents in JSON format. This confirms that our backend is functioning correctly and that it securely retrieves records only when the request is properly validated. You can get an idea from the given image. Third one is result. The result of our system showed that it successfully combines country metadata with COVID-19 statistics into one clean and structured output. All stored records in MongoDB include every field, include the timestamp and the authenticated user identity. Our client interface also displays these results neatly. This shows that the full data flow from external APIs to the client, then to the backend, and finally to the database work smoothly and end to end. You can get an idea from the given images. Other one is challenge and limitations. During development, we faced several challenges. We had to handle API rate limits, manage different country formats, and properly configure auth security. Some limitations still remain, such as dependence on external APIs and the lack of deep historical analysis. However, we can improve the system in the future by adding caching, supporting multiple authentication providers, and building advanced visualize dashboards. In conclusion, our project successfully demonstrates a service-oriented architecture that integrates multiple APIs, ensures secure communication, and stores validation data in MongoDB. Through in project, we gain practical experience with OAuth 2.0, RESTful API development, Node.js, Express, and client-side JavaScript. With our future improvement, the system can become even more robust, scalable, and suitable for deeper data analysis. Thank you for watching our presentation. Thank you.